Here we are continuing our integration using infinities. So we're looking for we're looking for the area under a curve on an interval. So let's sketch a graph of this first. This is similar to the graph of 1 over x squared, but it is shifted 3 to the right. So let's say here's 3. We have a vertical asymptote at 3. If we plug in 0, we get 1/9, so pretend that's 1/9, some small value. Okay, so it looks something like this. And we are just looking for the area from 0 to 3. So we are just looking for this area right here. Now the issue here is even though 0 and 3 are finite limits, at 3, the function does not exist, okay? We can't plug 3 into this function. So instead what we need to do is we need to say we're going to go from 0 to, and then again pick a new variable like t. So we're going to go from 0 to t, and then we're going to say let's let t approach 3. Now in this case, because it's not positive or negative infinity, we need to indicate which side we are coming from. So this is going to be the limit as t approaches 3 from the left. Okay, so for our area is going to be the limit as t approaches 3 from the left of the integral from 0 to t of 1 over x minus 3 squared dx, or you could write that x minus 3 to the negative second. Okay, so integrating this, if you want to write out the u substitution, you're welcome to with x minus 3. du is just 1 dx, so I don't need to rewrite that. So this is u to the negative second. Okay, so then my integral is equal to the limit as t approaches 3 from the left. Let me move this over a little bit. And then my antiderivative is going to be negative 1 over x minus 3 to the first. And we're evaluating from 0 to t. All right, so continuing that, limit as t approaches 3 from the left. And we are plugging in t first, so we have negative 1 over t minus 3. And plugging in 0, that's going to be minus a negative, so I'm going to make that plus 1 over 0 minus 3. Whoa. 1 over 0 minus 3, okay. All right, so this right here, actually, let's do this part. This is just negative 1/3. That's a constant, no problem there. This one right here is where we have an issue, though. If we plug 3 as we approach from the left into this, we are going to approach an infinity. Specifically, this is going to be negative 1 over, if I do 3 from the left, minus 3, that becomes negative 1 over something slightly less than 3, minus 3 is something slightly less than 0, so we could write that 0 minus. And so I have a negative 1 divided by a very, very tiny positive or negative number that approaches positive infinity. So either way, this goes to infinity, so we are going to say it diverges. Okay, therefore diverges. All right. Okay, let's do one more. So here we are looking for the area under y equals natural log of x. Okay, so natural log of x looks like this. It does have an asymptote here, 0. Okay, between 0 and 1, because this is below the x-axis, I'm going to have to put a negative in front of the whole thing. You can put it in front of your integral, or you can put it in front of the limit, does not matter. But our area, to find area, we're going to have to do the opposite of, and I'm going to put the limit in front, or the negative in front, the limit as, and I can't go from 0 to, here, let me write it without that first. It's going to be the opposite of the integral from 0 to 1 of natural log of x dx. Okay, if I write it like this, though, I have a problem because of the 0. That's where I need the limit. So I'm going to do negative, and then the limit as t approaches 0 from the right, because I'm coming from this side, and then of the integral from t to 1 of natural log x dx. To evaluate this integral now, I do need to use integration by parts, okay? So u is going to be natural log x, du is going to be 1 over x, come on pen, my battery is dying, dv is 1 dx, and v is x. Okay, so then that becomes the limit as t approaches 0 from the right of, and then we have uv, so I'm going to put the x in front, x, natural log x, and that is still, it's a definite integral, so still evaluated from t to 1, minus the integral from t to 1 of v times du. So v times du, oh, forgot my dx right here. V times du, x times 1 over x is just a 1. Okay, and so that becomes the limit as t approaches 0 from the right of, so plugging in, I've got 1 natural log of 1, which is just a, this is a 0, so that's going to disappear, minus t natural log t, and then minus, the integral here is an x. I'm going to go ahead and evaluate that at the same time. So I have an x, but I'm plugging in 1 in t, so it's going to be 1 minus t. Okay, so if you want to write that in an extra step, this integral right here is x from t to 1, so that we have 1 minus t when we plug that in. Okay, I just didn't want to rewrite the rest of it. Okay, so then we have the limit as t approaches 0 of, this is a 0, this is a 0 times infinity. 0 times infinity is an indeterminate form, so we are going to have to use L'Hopital to evaluate that part of our limit. So I'm going to leave this as t times natural log t, but 0 times infinity is not one of the forms that L'Hopital works for. However, if I take this t and I move it down as 1 over t in the denominator, now I have infinity over infinity, okay? And I'll show that here in a second. Natural log t and 1 over t, and then minus 1, and then plugging in 0 from the left or right doesn't matter, that this becomes a 0, so that's gone. Okay, so now we can split this as two limits. So limit as t approaches 0 of natural log t over 1 over t, and then minus, well, the limit as t approaches 0 of 1 is minus 1. Okay, so let's look at this part. Okay, checking numerator and denominator. Limit as t approaches, oh, forgot my from the right. As t approaches 0 from the right of natural log of t, that goes down to negative infinity. And then the limit as t approaches 0 from the right of the denominator, 1 over t, that goes towards positive infinity. So L'Hopital does apply, okay? So that becomes the limit as t approaches 0 from the right of the derivative there is 1 over t. Oh, I just realized, hold on a second. I forgot to carry my negative through. Let's back up. Negative, the negative right there, put the negative there, put the negative here, put the negative here. So that's going to be a plus 1. Okay, so negative there, sorry. Okay, 1 over t, and then negative 1 over t squared for the derivative of that. And I still have now I have a plus 1 at the end because that negative applies to the whole thing. Okay, so evaluating or simplifying this limit, I get negative limit, and you could skip this step if you want to just simplify over here, but I'm going to write it out. As we approach 0 from the right, 1 over t all over negative 1 over t squared becomes a negative, so I'm going to move that over here and make that a positive, and then t squared over t reduces to a t, and then I have a plus 1, so I end up with 0 plus, because limit is t approaches 0 from the right of t is just 0, plus 1 is 1. Bam. So the finite area of this infinite region here is equal to 1. Now, is it likely that you're going to have to use L'Hopital inside one of these improper integrals? Not necessarily, but it is quite possible, so we need to make sure that we remember how L'Hopital is applied.